Hey guys, Mr. Middleton here. Today we're going to talk about rate of change. At the end of this video, you should be able to find the rate of change between two data points, and you should be able to put your answer in the context of the problem. Okay? Alright, so rate of change allows you to see the relationship between two quantities that are changing. Okay, and in a line, the rate of change is constant. That means it stays the same throughout the line. Okay, so rate of change, you're going to find that you're basically going to say how much does y change over x, or change in y over change in x. Okay, later on you might see that as like change delta y, delta x. Okay, all right. And to find the rate of change, right now we're going to look at finding the rate of change from a graph. So basically, gone through here, rate of change just says how fast is something changing over this other measurement that we're measuring. And this is a good example here, price of oregano. The cost is measured in the y-axis of the vertical, and the weight is measured on the x-axis of the horizontal. So let's choose 2 points. I'm going to choose, I'll say 0. It doesn't really matter which points I choose. I'm going to choose this point and this point. Actually, I could choose this point, but this is 1/2. Probably not the point that I want to choose. I'll choose this one at 0, 0. Okay, that way I don't have to mess with decimals or fractions. Okay, so from point 1 to point 2, how much does y change? Well, it goes from 0 to 1. So how much does it change? Changes 1. Or plus 1. Okay. How much does x change? It goes from 0 to 4. So plus 4. What's the rate of change? Remember, we're doing change of y over change in x, so 1/4. Okay. And that's just a fraction, but for this situation, we want to know what it means specifically. Okay, so what is usually you can do this by just looking at the units that are being measured. Y is being measured in dollars, and x is being measured in ounces. And so what does this mean? Well, it means that we have the price increases $1 every 4 ounces. Every 4 ounces. Okay, so not super difficult, just looking to see basically that we know what's being measured. Okay, and we can choose from another point. Let's look at this. Hopefully I didn't mess up. That's the point right here. Okay, so we will have to run into a fraction. So looking at from point 2 to point 3, how much does y change? Well, this is 1.5. Goes from 1 to 1.5. How much does it change? 1/2. Okay, it goes up plus 1/2. Okay. How much does x change? Well, x goes from 4 to 6. So x changes 2. Again, we want to find out what the rate of change is. And now we're going to make this, I'll make this reason that I wanted to avoid the fractions in the first place, or the decimal in the first place. We have 1/2 over 2, or 0.5 over 2. If you use your calculator or do that some other way, make sure I take this calculator off when I'm done with it. Okay, 0.5 divided by 2 is 0.25. Okay, 0.25 is the same as 1/4. Okay, notice that the rate of change, no matter if I use points 1 to 2 or 2 to 3, the rate of change stays the same. It's the same. And that's what I said at the beginning, that the rate of change in a line will be constant. All right. Okay, so now looking at this next situation, we have a tank of gas, the fuel in the tank measured in gallons, and the miles traveled. So, how much does y change? Let's choose 2 points. Okay, so y is here at 15. I'm going to try to choose a point that's easy to read, and one that I think is easy to read here is at like 150, because that's how far over right it goes, and 5, that's how high it is. So how much does y change? Well, y goes from 15 to 5, so it means it goes down -10. Okay. How much does x change? Well, it goes from 0 to 150. So it goes up 150. And now what's the rate of change? Well, I'm going to put those numbers. Remember, change in y is -10. Change in x is 150. And I'm going to simplify that. I always want to make sure my fractions are simplified. That's -1 over 15. Okay. In this situation, what's that mean? Again, that means we're focusing on the units here. So 1 gallon, 15 miles. So it looks like your car uses 1 gallon of gas every 15 miles. Okay, or miles per gallon is what a lot of times it's measured as. Alright? So nothing too difficult there, just making sure that we're being consistent, making sure we put y over x, and then that we're making sense of what's happening in our fraction in our graph. Flipping over to the back side, we'll find the rate of change from a table. Sorry about my handwriting. Okay. All right. So what we're going to see here is when we look for rate of change, we're basically doing the same thing. We're going to see how much does, remember that this will be x, this will be y. We're going to look at how much does x change over, or y change over x. And so we can just look and see, okay, how much is this changing? From here to here it's 2. From here to here it's 3. From here to here it's 1. Okay, and we found all that just by saying, okay, that's 7 minus 5 is 2. 10 minus 7 is 3. 11 minus 10 is 1. Okay? Alright, and now on this side what we're going to do is we're going to see how much that's changing as well. So from 105 to 75 is 30. From 105 to 150 is 45. And from 150 to 165 is 15. And you'll notice that all these numbers are different. But we need to see, is this a constant rate of change? Because if it is constant, then we know that it's going to be a line. And if it's not, we know that it can't be a line. So what we do is we say, okay, well, let's make this a fraction. Remember, our rate of change is the change in y over the change in x. So here it's 30 over 2. Okay. Here we have 45 over 3. And here we have 15 over 1. Okay, so these should all simplify to the same thing. So 15 over 1 is simplified already. 45 divided by 3, that simplifies to 15 over 1, right? If we divide both by 3. Okay, that gives us 15. And then here, that also gives us 15 over 1, right? Divide both by 2, 15 over 1. Okay, is the rate of change, is there a constant rate of change? Sorry, yes. What is the rate of change? It's 15 over 1. So what does that mean in this situation? In this situation, the cost is 15 for every one ticket. So that means each ticket costs $15. Okay. All right. Moving up. All right. Second, our different problem. 0 to 20, that goes up 20. That goes up 10. That goes up 50. Okay, we'll do that here. Goes up 5. That goes up 3. That goes up 4. Okay, we'll do the same kind of setup, and so we have y over x, so 20 over 5, that's 4. 10 over 3, that's 3 1/3, or I guess I should say 4 over 1. 10 over 3 is as simplified as it gets. Then we have 50 over 4, which simplifies to 25 over 2. Okay, and so you'll see that is not a constant rate of change. Okay, the rate of change here was 4, and the rate of change here was 10 over 3, and the rate of change here is 25 over 2, and those are not equal to each other. Okay, and so it's not. So there is no rate of change in this situation. So he was not running at a constant speed. Okay. All right, and then finding the rate of change from a situation. Or formula, probably. Okay. All right. So the baby giraffe. So we can find a rate of change, what we've seen from a graph, from a table, and now from a situation or story. And basically we can take that and move it into a table or whatever. So a baby giraffe was 70 inches tall at birth and 103 inches tall after 3 years. What 2 points of data can we get from this? Now it's important to remember that most of the time, time is x, is the x. Okay, and so for these two things, we know the baby's height at birth. That time is, let me make a table here because that helps me out. That time would be 0. At birth, he was 70 inches. Age and height in inches. Okay, he was 70 inches. At 3 years, he was 103 inches. Okay, we only have one, or actually 2 sets of data, and so our rate of change has no chance to change. But from this point, the 2 points of data that we have are 0, 70, and 3, 103. We can find the rate of change, again, just by doing the change in y, so this has gone up 33 over 3. And that simplifies to 11 over 1. And with graphing, we'll like to keep these as fractions. Okay, and in this situation, it means that the height increases 11 inches per year. Or the giraffe grows 11 inches per year. The age is in years, right? All right. Last situation, last problem here. After 3 days, the farmer collected 38 total eggs. After 7 days, he collected 194 eggs. Again, so I'll go with days because generally time is going to be our x, and I'll do eggs, or the number of eggs. Here's our y. So it says at 3 days, or after 3 days, he collected 38 eggs. and after 7 days, he collected 194 eggs. Okay, so the data points, 3, 38, and 7, 194. We can find our rate of change here, 156. Right on that? Hope so. And this is 4. Okay, so the rate of change is 156 over 4. Probably we'll try to simplify that. I'm sure we can. And that will give us 39 over 1. Again, we want to keep it as a fraction so that we can make sure we take both units into consideration when we're asking what does this mean to us. Okay, and what it means is that the farmer collects 39 eggs per day. Okay, so farmer could collect however many eggs he wanted, but based on the situation that we have, he collects 39 eggs per day. All right, so rate of change, basically looking at what's happening, how is y changing when x changes, and what does that mean in the situation. All right, see ya.